Hi there. Today we're going to be looking at the division of decimals. We're going to be looking at this lesson in 3 parts, and part 1 is dividing a decimal by a whole number. Let's just quickly start with a whole number by a whole number division. 384 divided by 3. Nice and straightforward. If we're using our short division, 3 goes into 3 once, 3 goes into 8 twice, remainder 2, 3 goes into 24 8 times. So we have our answer of 128 using short division. Now, let's do it again, but this time the number is a decimal. What are we going to do this time? Well, it's almost exactly the same. There's just one thing we need to remember. So we're still going to use, let's start again. We're still going to use short division. We have a decimal point here now. So 3 goes into 3 once. We need to put the decimal point exactly above its position here. 3 goes into 8 twice, remainder 2. 3 goes into 24 8 times. So our method is almost exactly the same. We just need to remember to put the decimal point in completely in line. Let's write that down. So we're going to line up the decimal point in the quotient with the decimal point of the dividend. Maybe we need a quick little reminder about those terms as well, quotient and dividend. So let's just put another little learning bubble in here. Okay, the number that we start with, that is our dividend. The number that we are dividing it by is our divisor, and our answer is our quotient. All right, so that's just a little reminder of the terminology that we use in division. Right, let's carry on. Let's move that up a little bit so you've got... So, question 3. Very similar, but let's just have a look. We've got a load of decimal points. We just need to be a little bit careful here. So we're still going to proceed in exactly the same way. But the key thing is to make sure we match. So we just need to copy up until we get to this point, and then we can start. 3 goes into 3 once, 3 goes into 8 twice, remainder 2, etc. So just make sure you're copying in the same way that we copy up the decimal point. We want to copy up all our zeros, our placeholders, to make sure that we still get that decimal point in the correct place. Another example. Now this time I've got a larger number that I'm dividing by. So this time, instead of using short division, I'm going to use long division. I'm going to see how many times 13 goes into 35. I might start writing them out to help me because I don't know my 13 times table off the top of my head. So just here on the right hand side, I'm going to start listing out sum of the 13 times table. I can now see that 13 goes into 35 twice, that's 26. And then I can work out the difference, so that I'm going to have the difference between 35 and 26 is 9. I'm now going to drop down my 1. 13 goes into 91. Well, I need to keep going, don't I, with my 13 times table. I've got 65, then 78, then 91. I can see that 7 lots of 13 give me 91. So my answer is 27. So that's just a quick reminder of long division. And it works exactly the same if you have a decimal here. Let's see. So now I've got 3.51. I'm still dividing by 13. I'm going to do exactly the same as I did before, but I've got 3.51 this time. 13 doesn't go into 3, so I'm going to write 0, and I'm going to drop the 3 down. I'm going to bring down my 5. 13, remember, note here that I've not dropped down my decimal point. 13 goes into 35 twice. Sorry. Not paying attention. 13 times 2 is 26. I'm going to drop down now. I've got 9 left over, and I'm going to drop down my 1. 13 goes into 91 7 times. So my answer in this case is 0.27. Sorry you didn't see all that. Okay. Now just a quick reminder here. It doesn't apply to some of the questions we've done so far, but we want to simplify first. If we can simplify, let's do it. It's going to make life a little bit easier for us with some of these larger numbers. So for example, question 6, so I'll pop that there. 336 divided by 48. Okay, I'm going to write this as a fraction. 336 divided by 48, I'm going to write it as a fraction. So I'm going to have 336 divided by 48. It's exactly the same calculation, I'm just expressing it in a different way. I want to simplify it because I don't know my 48 times tables. Now I might be able to see that both of those numbers are divisible by 4 or 6 or even 12. But if I can't be sure, I can definitely see that they are both even numbers, and therefore I can divide the numerator and the denominator by 2. Again, they're still both even numbers. I can do exactly the same again, dividing the numerator and the denominator by 2, and so on until I've no longer got an even number, but I can see now that both numbers are divisible by 3. You probably could have seen that back here or back here. But as I say, there's nothing wrong with just breaking it down and dividing by 2. Now we're going to come back to this fraction method later. Let's do one more question. See if I can squash it on the bottom here. Can you see? All right, so 23.1 divided by 5. Okay, it's just very slightly different. So I just want to make sure that you're clear on what to do here. We've got 23.1. 5 goes into 23 4 times remainder 3. It goes into 31, remembering to put that decimal point there, 6 times, but I've still got a remainder 1. So this is where I want to add in a 0 as a placeholder, which allows me now to put my 1 in here, and 5 goes into 10 2 times. So whether you do it using short division or long division, it doesn't matter. The key thing is to add a placeholder here so that you can get your answer to 2 decimal places, in this case 4.62 being our answer. Okay, right, let's move on to part 2. Okay, so now we're just going to look at division by 10, 100 and 1000. And to start us off, just quickly, we're going to do a recap of multiplying by 10, 100 and 1000. Okay, so if we're multiplying, to multiply by 10, we move the place value once to the right. Sorry, getting mixed up now, because I'm in division mode. Once to the left. If I'm multiplying by 100, I'm going to move my place value. These little ditto signs mean just copy down what's on the line above, twice to the left. Okay, and at school, and I wouldn't be crazy enough to sing it, but at school we call this particular one the Beyonce Method. Because, and I'm not going to sing it, but I'm singing it in my head, because we move the place value to the left, to the left. Okay, I'm going to leave it there. So now let's look at division. So if we're dividing by 10, we want to move the place value once to the right. Similarly, if we're dividing by 100, we're moving our place value twice to the right, and so on. Obviously, if it was dividing by 1000, it would be 3 times to the right. So I said we were going to do a little bit of recap of multiplying as well. So let's start off with that. First few questions. 26.6 multiplied by 10, moving the place value to the left once. To the left is going to give us 266. Question 2. 4.327. This time I'm multiplying by 100. I'm moving my place value twice to the left using my Beyonce method. 432.7. And question 3. 0.0082 multiplied by 1000. Again, moving to the left, but this time 3 places is going to give me 8.2. Let's do the same again, but with division. I'm going to use the same numbers. 26.6. This time I'm dividing by 10. That's going to give me 2.66. Question 5. 4.327. This time I'm dividing by 100. Okay, sometimes it can be helpful if you just add a 0 in there. That might help you with moving your place value. This time you're going to get 0.04327. because we've moved 2 place values to the right. Okay. Finally, I've got 0.0082 divided by 1000 this time. Again, you might find it helpful to pop in a couple of zeros here. This time you're moving to the right 3 places. So you're going to end up with loads of zeros. 0, 0, 0, 0, 0. I need to double check and count those to make sure I've got it right. So I've started with 0.0082. I've moved 3 to the right. So I started here and moved 3 to the right. And I end up with 0.00000082. So there are 5 zeros after the decimal point. Okay. Let's look at how we use that for some conversions. And it's probably worth just recapping those conversions here. So all those calculations that we do are to help us with conversions. So just a reminder, we're not going to do all of them, but we'll do some of the main ones. For length, 1 kilometre equals 1000 metres. 1 metre equals 100 centimetres. And 1 centimetre equals 10 millimetres. And if you get caught on a conversion question, don't forget you've always got a ruler in front of you, and that can help you see that, for example, here 1 centimetre is 10 millimetres. Let's look at mass. 1 kilogram equals 1000 grams. Capacity. 1 litre equals 1000 millilitres. And you will also sometimes see on your water bottle, you might see it written as centilitres. Time, we've got to be careful on time, really careful with our conversions when it comes to time, because it's not 10 or 100 or 1000. 1 hour is 60 minutes and 1 minute 60 seconds. I know I'm stating the obvious there, but all the time I see mistakes where people have forgotten and they've divided by 100 instead of 60, for example. And finally, money, obviously £1 is 100 pence. All right, so just a couple of quick questions there. So if I had 300 grams and I wanted to write it in kilograms, I would take my 300, I would divide by 1000, and that would give me 0.3 kilograms. And if I had 4.1 litres and I wanted to write it in millilitres, then this time I am going to take my 4.1 and I'm going to be multiplying it by 1000 to give me 4100 millilitres. All right, just one more. If I have 7.8 metres and I want to write it in centimetres, I've got my 7.8, but this time I'm not multiplying by 1000, it's 100. Remember, centi for centimetre, cent means 100. So 7.8 multiplied by 100 gives you 780 centimetres. Okay, finally, part 3. This is division of a decimal by a decimal. Division of a decimal by a decimal. Right. So here's my question. 3.2 divided by 0.2. Let's just pause and look at that for a moment, because this is the type of question that can look a little bit scary. But if we remember what we talked about back in part 1, when we converted it, we wrote this, or a similar question we wrote as a fraction. Okay, so I'm going to rewrite it as 3.2 divided by 0.2. Okay, so let's put that in a learning bubble. Write the calculation as a fraction. And now what we need to do is we need to work to change this denominator so that it is no longer a decimal. We want this to be a whole number. So let's look at how we can remove the decimals. So I've got 3.2 divided by 0.2. If I use my equivalent fractions and I multiply my numerator and my denominator by 10, I'm going to get 32 over 2. So suddenly, a calculation that seems quite difficult and certainly not intuitive, we turn it into something very simple. 32 divided by 2, or half of 32, being 16. Okay, so let's make a learning bubble there as well. So once we've written the calculation as a fraction, we need to make the divisor, the denominator, because we've written it as a fraction, a whole number. So we're making the divisor, the denominator, a whole number. Right, one last question then. So this time I've got 23.8 and I'm dividing by 1.4. I'm going to write it as a fraction, 23.8 over 1.4. I'm going to do the same as up here. I'm going to multiply my numerator and my denominator by 10 to get rid of my decimals. So I've got 238 divided by 14. Okay, let's write that over here. 238 divided by 14. Now I could just use either short or long division to solve this, but I'm not great on my 14 times table. But luckily I've noticed that the numerator and the denominator are both even. So I can simplify it. I can divide the numerator and the denominator by 2. That's going to give me 119 over 7. And now it's a much easier calculation for me to do, because I do know my 7 times table. 7 goes into 11 once, remains a 4. 7 goes into 49 7 times. So I get an answer of 17. Okay, so let's just put our last learning bubble here. Once the divisor is a whole number, see if you can simplify the fraction. Okay, you don't have to do that, but it just makes it easier. Just one comment finally, is that it's okay if you still have your numerator as a decimal. It's the denominator that needs to be a whole number. So if your numerator is still a decimal, that's absolutely fine. You just go back and do exactly the same method as we were doing in part 1. Thanks very much.